Welcome you all to my YouTube channel, and today we're going to discuss about NumPy library. So NumPy library in Python is used for working with arrays. I really like NumPy library because it gives me great functionality working with mathematical operations, matrix operations, linear algebra, Fourier transforms and all. And the question arises in our mind is, why do we need a NumPy array though we have a list in Python? But the thing is, a list doesn't allow us to do the any functionalities faster. They are very slow compared to NumPy array because NumPy array are defined in C standard templates. Although NumPy is a library in Python, it's partially written in Python, but it's most of the code is written in C++ and defined using C standard templates only. And also it's really great working with current CPU architecture, advancement in CPU architecture, right? So it's give around 50 times faster access to the functions and all compared to the normal list. And also they are stored in the continuous memory addresses, so it's really great to manipulate the data in it because really easily accessible, right? So that's all about NumPy and why do we need to learn the NumPy and why should we use it on our regular basis in machine learning, data science, right? Deep learning. So first of all, let's go starting with how do we import the NumPy. So that's really easy. Import NumPy, and we need to give it an alias. It's a kind of a good practice in Python. Rather using NumPy every time, just use NP. So we are defining NumPy as NP here, right? Now defining a NumPy array from a list is really easy. You just need to do np.array and it will convert this particular list to an NP array. As you can see, if I type a, it's an array, and if I see the type of this a, right, then it would be an np.nd array. Though it's a linear array, if you want to convert into a two-dimensional or n-dimensional array, then what you can do, you can just define it in another way. That would be np.array 1 2 3 and you have 4. And now let's see the a. And earlier, if it was like this, if it was the a, then let's see the shape of it, and it is linear array. Now I've defined it in the n-dimensional format, so let's see the shape of it. It would be 4 cross 1, right? So that was how we're going to define the array, right? Now let's see, in machine learning we generally need to define the zero array, one array, or identical array. For that, the NumPy gives us the great functionality to define all those things. Let's define a zero array, so that you can do just zeros, I think. And here you need to define what should be the shape of your array. And let's see the array. Now you can see the shape of my array is 4 cross 4, and all are defined with 0 as their elements in it, at all the indexes. And if you want to define the array with all the ones element in it, then that's really handy. You can do it like this. That's all. And the question arises, what is the data type of this particular element in this? Let's see that also. Type a of 0 of 0, right? I hope you know the indexing, how we gonna do the indexing, right? I know you are familiar with it. If not, then please just Google it. It's really easy. The indexing start from 0 1 2 3, right? If you want to access this particular element, the indexing is a of 0, a of 1, a of 2, a of 3. The indexing would be different in this particular 2D array because it's a 2D array, right? It's a 2D array. So here, if you want to access this particular element, right, then what you're gonna do, a of 0 will give access to this particular array, this particular list, and of 0 will be giving this element. So if I give it 1, right, and if it is just a linear array, then it would be a of 0 will be giving us the 1, right? So you should be familiar with the indexing part because that's really important. Now let's as we have going through that, it was a float and we want to get convert into some other data type, that we can do really easily, that d type double equals to np dot int 64. Right, now as you can see, those ones that were in float earlier now are converted into the integer data type. These are the small things you should be familiar with, because they are really handy in machine learning, right? And we do need them in while writing any algorithm like linear algebra, and or like those things in linear regression, logistic regression. You should be having a good idea, intuition behind how to change the data types, how to declare the array with all the 0 element, 1 element, like that, right? Now we're gonna see how to define an array with all the same element, but the element of your if of our choice, right? For that we can just do equals to np dot full, and here you will be giving the shape that I'll be giving 3 3, and the element I'll be giving 5. And let's see the a. Now you can see the array is filled with the element of our choice, right? If I want to declare identity matrix, then that's also really simple. So first of all, what is identity matrix? Identity matrix is a matrix which is square matrix, and only the diagonal elements are filled, and that to be with the 1, right? So you can do it by np dot eye, np dot I, and give it the uh, dimension of the array. And now let's see, as you can see, only the diagonal elements are filled, and the shape of matrix is 4 cross 4, and the diagonal elements are filled with 1 itself, right? Now we should be moving forward and gonna see the mathematical operations on the matrices. Let's take the 2 numpy array. I'll be filling them with this, just put them in the list, right? And just change the values to 3 4 5. Let it be b, right? Now the mathematical operations are really easy. If I just need to add the 2 elements, 2 arrays, then it's really easy. What it is doing, it is doing element wise addition. So it is 1 is added by 2, 2 is by 3, 3 by 4, 4 by 5, right? That's the result we have. A minus b is also really easy, right? Multiplication is also really easy. This will give us the element wise multiplication: 2 into 1, 3 into 6, 4 into 3, 4 into 5. Division is also easy. And not using this, we can also do it by like np dot add a comma b, same thing, np dot multiply, right? We are getting the same thing. Also, if I want to get the sum of this particular array, what I can do, I can just write np dot sum, and here a, right? It will be giving me the sum of the whole array. If I give now the thing I want to make you notice here is, like earlier when we were doing a plus b, then what I was getting the addition in this direction, right? Like what if I want to get the addition in this direction row wise, right? For that we can use np dot sum a comma b, and we can define the axis to be in that direction 1. Now you can see 10 14, 10 is the addition of this particular array, and 14 is the addition of this particular array. And if I do the 0, you can see the additions is like column wise addition. Earlier it was row wise addition. So how we gonna memorize that, what result gonna come when we put x is equals to 0, what result gonna come when x is equals to 1? So basic simple understanding from which I have an intuition about this is, whenever it is a 0, consider 0 as a ball. So ball is always pulled towards the gravity, so ball gonna move from upward to downward, right? So it would be 3 5 7 9. And if it is 1, consider 1 as an arrow, so arrow move like in the straight direction, right? So we're gonna do in the row wise. So if it is 1, then it would be 10, 14, right, like that. So this is the basic understanding. If you want, you can use it. Otherwise, you can have your own other method to make yourself understand what how the changing of the axis can change the results, right? The same thing can be done with the subtraction, I think, multiplication, right? And earlier we were doing the dot wise multiplication. Sorry, element wise multiplication. Like if I was multiplying AB, then it was 1, 2, 2, 3, 3, 4, 4, 5. Now, what if I want to do the dot product? For that, let's have a array, right? So earlier in the element wise, what was happening if I was doing just np dot multiply AB, then if 5 1 would be filled in one array, right? Let's make one more array, be 18, and right. So it would be in the element wise multiplication, it would be 5, it would be 12, it would be 7 3s are 21, 1, like this, right? We're gonna fill it element wise, but in the dot product, what we're gonna do, we're gonna just uh, I hope you have a good understanding about dot product, right? It would be like let's so it would be like multiplying these elements with these elements for this particular shell, and for this shell we're gonna multiply these elements with these elements. For this shell we're gonna multiply these elements with these elements. Now how we're gonna multiply for particular this shell? If I see these elements gonna multiplied by these shells, so 5 into 1, 6 into 1, that is 11, 7 5 35, 35 plus 11, that is 46. So 46 would be filled here, right? So it would be filled like that. This is the dot product. If you need in some like in deep learning for the neurons, you need to do the dot product with the weights, and also you can use np dot dot there, right? And there's a functionality for that also, right? That is, if I want to do the dot product between these two elements, element product we have considered earlier. Now the dot product will be a dot dot b. That's all. It will be giving us 40. You can do it by yourself. Suppose uh, it is 1 cross 1, it would be 1 cross 2. Suppose it is some different array like this, 2 comma 3 comma 5, right? Now a dot b would be, the shape is not aligned, right? The shape is not aligned. Okay, there's the shape should be equal for doing the dot product, and 2 comma 3 comma 5 comma 6. I hope now it's gonna work. 2 comma 4, right, right. Now this is right. Here we have shape to be 2 comma 4, and this is 4 comma 1. Now we do it. This is gonna be the dot product, right? Okay. Now let's see how we're gonna reshape our array. Suppose let's see the shape of A. Shape of A is 2 comma 4, right? If I want to reshape it, and let's print it. Now if I want to reshape it 4 comma 2, we can do it really easily. That can be A dot reshape, and just give the uh, reshape values you want to change it to. That would be 4 comma 2, and you can see here, and also you can see the shape here, it's 4 comma 2, right? So that's really easy reshaping the elements. Or if you don't know what is the column value, you can just put -1. It will by itself check what could be the value here if it is suitable to do, right? Now the next thing we're going to see how to stack two arrays, like horizontally or vertically. Stacking is really easy in Python using NumPy library. NumPy have a handy function known as np.stack. In that, what we're going to do, we're going to just pass the arrays we're going to stack, right? And what the stacking means is, what if I want to just add these two array into a single two-dimensional array? Means this 1 2 3 4, and in the second row it would be 2 3 4 5. Then what I can do, I can do x is equals to 0, means along the rows. So as you can see, it just did along the rows, right? And what if I do just need to along the columns, then it can be stack a comma b axis equals to 1. I can see it is along the columns. So these are the two kind of stacking you can do, right? You can also reshape it. We have seen the reshape function earlier, right? Earlier we have seen how to reshape an array. Now let's move towards the random function. So first thing, as we have used also earlier in our previous video, arrange method, right? So it's gonna give us the array till the range of 10, that to be from 0 to 9. It's a really handy function while getting an array for that. Now there's also some random functions in Python in NumPy array, right? So first is np.random.rand, and here I will pass the shape, that would be 3 comma 3. Okay, np.random 3 comma 3. Yeah, it is fine. What is the issue with it? Cannot be interpreted as integer. Let's just remove this one and let's see. Yeah, here you can see the random values are initialized in the array of shape 3 comma 3. And if you want to initialize the random array with a normal distribution of these values, these all values, then you can just use np.random rand n. If I show you, these are normally distributed values, means the mean of these values is 0 and standard deviation is 1, right? So this is really useful while initializing the weights in neural networks, because that will help us to converse our module really easy in really less time, right? So you should be, this is really useful function in using neural networks, right? Now the next thing we can see is uh, suppose we need to get the some random values between random dot rand int, I think, yeah, rand it. So here I'll be passing the range 3 comma 10 and how many values I want between these. I want 3 values. Then as you can see, 336 means between 3 to 10 I'm getting 3 values as an integer. Now it will be different every time, right? What if you want to get the value same every time? You can just use the seed method. So basically what this seed method is, you define np.random.seed to be anything you want, like 3, right? So now as you can see, it would be same every time, it won't be changing, right? So this is really useful because if you know the seed at which the model is initialized, so you'll be getting the same result the next time you train it again. There's also one function that is shuffle. What if I want to shuffle my this suppose this array only, so I can use np.shuffle. Shuffle, I think it is like this only, np.random.shuffle, random.shuffle, right? I'll be passing the array, and if I check the A array, now it is randomly shuffled, right? And also there is a function called choice function in NumPy array, and that is really useful for getting a single element from a NumPy array. So choice into A, so it will just return the element, right? Every time different every time. And also if you want to set that, you can set the seed value here. Now that's all about the random function. Now we're gonna look about the statistics function in this using NumPy array. Earlier we have seen the addition, subtraction, multiplication, dot product and all. Now we're going to see the actual statistical method like standard deviation, mean, variance, average, and all these functions, right? So let's define an array to be np.array and let it be right. If I just print it, it would be looking like this. Now if I want to get the minimum element out of this whole uh, np.minimum, now it will be giving the 1, and if I want to get the maximum element out of this whole array, it would be like this. I can perform the axis operation also. Axis equals to 0 means the downwards part, right? Now here I'll be getting the maximum element along the columns. If I just put it 1, then I'll be getting the maximum element along the rows. So here the maximum element is 4, here the maximum element is 34, here it is 45, like this, right? So the same thing goes for minimum also, right? Also, if I want to get the mean of A, it would be 10.5. Mean is means addition of all the elements and dividing by the number of elements. If I want the mean to in the axis format, like I want it in the column wise, then it would be 0, axis equals to 0, right? So mean along this column is 5.3, along this 27, along here 4.6, along here 5, like that, right? So this is mean, min max, and now we're going to learn about average. So mean and average are kind of similar thing, but in the average we take the what I can say, the weights also. Suppose this is our array, p dot array 1, 2, 3, and 4, and I also define the weights also. Weights is the same. If I define them, these are the weights, right? Now if I do np dot average and I give the value of arrays to be b and weights to be w, now you can see the average is 3. So basically what is happening here, it is multiplying the element with its weight. 1, 4, 1 plus 4, 5 plus 9, that is 14, plus 16, that is 30. 30 by uh, the average of total weights, that is 10. 30 by 10, that is 3. So here I'm getting the average value, right? Now here we comes the next one, that is standard deviation and the mean. That is really helpful in the linear algebra, right? In the linear regression also you're going to learn how to use standard deviation and all. So for that we'll be first seeing what is the formula for standard deviation. This is the formula basically. Here xi is the value and u is the mean and n is the number of those elements in that particular array. So let's get the mean, get the standard deviation and the variance. For that we also have a very handy library, that is NumPy only, and in that the for variance I just do variance of what, variance of A, let's variance of B, that is 1.25. And how it is happening, let's try to calculate the variance. So it is xi, it would be np.mean, np.mean, and absolute value of current value, that is b, minus, and let's take the mean, and that is np.mean of b, right? And we'll be putting it here and just do it square. Here n is not defined, it is m, that's why it is not defined. Now you can see the variance is same as while with the mathematical operation from the function, these two are same, and standard deviation is the under root of the variance, that would be np dot the function, that would be np dot std of b. It will be giving me 1.11. If I do np dot sqrt, so it would be 1.11. As you can see, both these are same, either calculating with mathematical operation or by the straight function, right? So, and also earlier I have mentioned that the I was getting the elements right. I have mentioned that defining the elements using random to random means getting the mean to be 0 and standard deviation to be 1. Let's check whether it is or not. np.mean of A is, let's see the A also. Here A is this, and np.mean is, okay, let's, it is very near to 0, right? It is very near to 0, right? Yeah, it is almost near to 0, and np.std, that is standard deviation of A, that is near to 1, right? So that if defining the mean and standard deviation to be 0 and 1 respectively, your model will converge fast, right? So thank you so much. Hope you get the clarity about NumPy and its all functionalities. I have covered everything about NumPy you need to getting started with machine learning in this one video. Thank you so much.